MAC if the OUI, if the first 6 hexadecimal is 01005E. Okay? In broadcast MAC, it's always all F. If you notice, like in the previous slide, it's all F. Okay, 12 F hexadecimal digits. That's for the broadcast MAC. Multicast MAC is 01005E. First, the OUI. Then the MAC address table. I mentioned that uh, a switch has the ability to send a frame specific to the destination. Unicast, right? That's good thing. Not like a hub. A hub, whenever it sends data, it sends it to all. It always uses broadcasts, and always using broadcast, it adds on the congestion. There's collision. There's too much traffic. Okay, so Switch has improved that by having a MAC address table. In the MAC address table, I have here, no, I have inserted here an example of a MAC address table. In the MAC address table, there is a mapping of the MAC address and to which port it is connected. Example, like example, this port 1, say this FA01. So this MAC address, let's say that's the MAC address of PC1. I'll just write the last 6 hexadecimal, okay? So let's say that's 66. This one, 66. And then for port 3, say this one, it has a MAC address of 68. So, since there's a MAC address table, so let's say PC1 will send data to PC2, okay? PC2. So, it maps the destination MAC, say 68, right? 68. So, whenever the switch receives this, it will check the MAC destination MAC, okay? In the MAC address table. And since there's a mapping of the MAC address, it sees that 68 is in port 3. So what the switch will do is to only forward it to port 3. Okay, so it will never be forwarded to all. Okay, again, we call this as a unicast transmission. Okay, sending the frame specific to the destination. Big question is how is this MAC address table built? Okay, so uh, so this is the discussion of that. So say when you buy a switch, so initially the MAC address table is empty. Okay, so the switch will build the MAC address table the moment that a computer, an end device sends a data. Example, let's map this. Let's say A is in 1, B is in port 2, C is in port 3, and then D is in port 4. Okay, say for example, A will send data to uh, D. It will send data to D. Okay, so sinend niya. So again, A sends data to D. The moment that the switch receives this, what the switch will do is to uh, check the incoming, the source MAC address in the incoming port. So it receives a frame in the port 1, in its port 1. So what the switch will do is to check the source MAC. So it will notice that that is A. Okay, so what it will do is to map the source MAC address, again take note the source MAC, to the incoming port. Like in this case, it is 1. So it has a common sense that, okay, I receive something in port 1 and the source MAC is A, therefore A is in port 1. Okay, after that, switch will check the destination MAC and then it will notice, okay, it's D, but there's no D here yet, right? So what the switch will do is to broadcast it. So there are still instances, but only a few, very a few, very few instances where a switch will broadcast or send to all. Like yun nga, like if there is no entry in the MAC address table, the switch will broadcast it, send it to all. So let's say D receives that, okay, and let's say D will reply, okay, it will reply to A. Okay, so again, switch will check the source MAC this time. So again, D will reply. So it sends something to A. So switch will again check the source MAC, and in this case, it's D. And then the incoming port is 4. So it knows that in port 4, the MAC address is D. Next, it will do is to check the destination MAC. Like in this case is A. So, and there's an entry of A. So the switch will never broadcast that. Okay, the switch will not forward that to all. So because it already has an entry here in the MAC address table. So what the switch will do is to only forward it to port 1. Okay, so that is how the MAC address table is built in our switches. Okay. One thing I can also share is, you know what, even small business type switch, example CDR King, there's a MAC address table. Okay, it's a standard that the switch should have a MAC address table. There's a memory inside the switch, and what one thing that is there in its memory is the MAC address table. A switch has this what we call as a frame forwarding method. It states in the forwarding method how a switch forwards the frame. So there are two forwarding methods in Cisco switches. We have store and forward and cut through. If a switch uses store and forward is the most commonly used, okay, what the switch will do is to read the entire frame. Okay, that's the keyword. Read the entire frame. Take note that inside the frame we have this. Okay, we have the preamble, the destination and source MAC, the length, the data, and the FCS. So up until here, all parts in the frame are being read if a switch uses store and forward. Okay, but take note, the good thing with store and forward is that first, it has error detection. Okay, this is very important, right? So with the switch alone, if it detects that there is an error, what it will do is to drop it. So at the point of the switch, that is good because somehow it adds on faster processing. Okay, dropping if there are any errors. It doesn't wait to go to the end device to process the error. Uh, but one big problem, one disadvantage that the store and forward has is it has high latency. The delay is high. The time to travel from PCA to PCB is high. Okay, so that's why there's another method which is cut through. Okay, in cut through, it only there's two type for cut through. Okay, so for cut through, there's what we call as a fast forward. So with the fast forward, it improves that part of latency issue in the store and forward. So the good thing with fast forward is that it has a low level latency, meaning the delay or the time of travel is lower, in effect faster in terms of the travel. Okay, take note that the switch, what only is needed by the switch is the MAC, right? The MAC address. Okay, so that's what we have in the that is what we have in the fast forward. The moment that the switch reads the destination MAC, what it will do is to automatically forward the frame. So the keyword here is this one. So reading the destination address. Okay. So so it skips this part here. It never reads the data. It never processes the FCS. Once it reads the destination address, that's it. So um, latency is lower, okay? But the problem is there's no error checking, okay? There's no error checking. So there may be instance that the switch will forward that, the destination device will receive that, and there's an error. So what will happen? Magre-resend. This is one reason why fast forward is not as popular as compared to store and forward. Still, most switches uses or prefer store and forward. There's another um, cut-through type of frame forwarding method and that is the fragment free. In the fragment free, the keyword is it reads the first 64 bytes, okay, of the frame. So somewhere in the middle, okay, somewhere in the middle, that's the what the switch reads. There are a couple of error checking like collisions and network errors, but not all errors are being checked by the fragment free. So next is memory buffering. In buffering, we have here the technique that the switch used to store the frame. Okay, so we have two port-based. So in port-based, frames are stored in queues in its specific incoming and outgoing ports. While in the shared memory, all frames are placed in a common memory buffer, shared by all switch ports. A switch has this feature we call as auto MDX. Okay, in other vendors they call it as an auto detect cable type. Take note, we've discussed that we need to observe the cable type if we were to connect devices, right? If you remember, say for example, if you were to connect a PC to a switch, we use a straight through, right? Okay. And for example, let's say there are no straight through available and you need to, right at that point in time, connect a PC to a switch. What you only have is just a crossover. Can you use that? Yes, if the switch has an MDX auto. So this is the use of this feature. Okay. So um, there. So with the MDX Auto, you don't you ignore the straight through and the crossover. So if you were to connect switch to switch and you only have straight through available, that is okay. That will work. Okay, if again the switch has an MDX Auto. Okay, that's the use benefit of this Auto MDX. Other brands or vendors also has this feature. So this ends this chapter. Keep safe. Together we learn as one.